Okay, good afternoon. Good afternoon, all. Right. Hope you can hear me. Let me share the screen. We are discussing the paper number 9, speed test number 9. Let me share the screen. Wait, I need to change the settings here. Okay. Okay. This is our paper. If there are any questions, you can ask me. You can unmute and ask me, or like you can, yeah, you can. I have opened my chat window as well. You can ask me any questions via chat, or you can unmute and ask any questions on this one, right? So question number 9. First one, the most electronegative one is, they're asking about magnesium, lithium, sulfur, bromine, and iodine. Now, in the periodic table, we discussed that from left to right, electronegativity is increasing because atomic radius is decreasing, right? So therefore, most of the time, the highest electronegativity atoms are in this direction, and lowest electronegativity atoms are in this direction. So basically, we can simply say in this area, highest En, here we can say lowest En, or we can say highest electron positivity. Electron positivity. Now, the special thing here I need to discuss with you. You can't see the screen now. No. Let me close this one. Right. Now, let me unshare and share it again, because you can't see that one. I need to see. Let me share this entire screen, then you will be able to see it. Okay. Right. Now, now we are talking. Now here, I need to talk about electron positivity here. Electron positivity is exactly the opposite of electron negativity, right? So if we talk in general, it's like this. Let's say there is an element like fluorine. Fluorine is having highest En. Having highest En means it is lowest electron positivity. Exactly the opposite one, right? And also, let's say an element like sodium. Sodium is having low electron negativity, or low electron negativity, and it is having highest electron positivity. So as a like, let's say, in general, as a theory that we can say, in the periodic table, if you take a periodic table, in this area, electron positivity, EP, is high. In this area, electron negativity is high, right? And also, electron positivity is directly proportional to R, because that is exactly the opposite of electron negativity, right? So electron negativity is inversely proportional to R in general. Electron positivity exactly the opposite of this one. So therefore, we can simply say electron positivity is directly proportional to R. These kind of things are small things, right? So let's go back to our paper. Now, so in that way, we can say electron negativity and electron positivity. If you take these values, magnesium, lithium, we can eliminate those things because those are having lower electron negativity. Magnesium is in the second group, right? This is in the second group. Lithium is in the first group. Sulfur is in the 16th group, right? So these things. And bromine is in the 17th group, and iodine is in the 17th group. Now we have a problem. Now iodine can be eliminated because iodine is having higher electron, higher atomic radius, because down the group atomic radius is increasing. If you have to check the periodic table first. If you check the periodic table, the 17th group is consist of something like this. The 17th group is having fluorine. 17th group is having fluorine, chlorine, bromine, iodine. So in this direction, electron negativity is decreasing because atomic radius is increasing from top to bottom. So therefore, bromine is having high electron negativity than iodine. So that is clear. Lithium and magnesium, those are out. But the other problem is, how about sulfur and bromine? Because sulfur is in third group, sorry, third period. And bromine is in fourth period. If you closely check, you can understand that one. Because chlorine is in the third period in the 17th group, and bromine is in the fourth period in the 17th group, right? So because sulfur is here, bromine is here. So they have some diagonal relationship, sulfur and bromine, right? Bromine definitely is having higher radius than sulfur. That is for sure. It is having higher radius than sulfur, right? So, but out of these two, due to the chemical characteristics, and also because it is having 17th group, bromine is having higher electron negativity than sulfur, right? You have to remember this point. Bromine is having higher electron negativity than sulfur. Even though bromine is having higher radius compared to sulfur, bromine is having high electron negativity. That is due to the chemical characteristics. Now, so therefore, this En inversely proportional to R is a general rule. It's not a fixed rule. So that's why it is not taught as a theory, right? So we are saying generally En is inverse proportional to R, but it is not taken as a theory. Theory is the Pauling scale. According to the Pauling scale, we are deciding the electron negativities. So that is something that you need to remember, right? So the answer here should be bromine, right? Not sulfur. So the answer is fourth one. Then the next question. Which one of the following is the highest, sorry, which one of the following is the first ionization energy is highest. That means highest first ionization energy. There is no argument. If there is something in the first period, they should have the highest electron or highest ionization energy. First period, highest ionization energy. If it is in the 18th group, that should be the highest, right? Because it is more closer to the nucleus and it is having only the one shell. So if it is having only one shell, if it is more closer to the nucleus, removing one electron requires high amount of energy, right? So if you check the elements here, what has been given, so this is in the second period, this is in the third period, this is in the second period, this is second, and this is first. So there is no argument. Helium is having highest ionization energy, right? So other no need to check. This is how you check the ionization energies, right, of this given set. Now, if you want to arrange this in the increasing order further, so helium is having highest electronegativity. Then out of these four, the second in the second period, we need to check for the second period. In the second period, we have neon as the highest. Then we have fluorine. Then we have beryllium. Finally, we have magnesium, which is having the lowest first ionization energy. We are talking about first ionization energy, not second, not third. If that is second and third, the things would be different, right? So therefore, we need to go for the answer is fifth one. If there are any questions, if there are any arguments, if there are any challenges, you can let me know, right? Then in the series of elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, the highest valency. Now they are talking about the valency, right? So the we need to be very clear on what is valency, right? So we need to be very clear on what is valency. So the valency is, right, what is valency, right? So the valency is, we can simply say something like this: the number of electrons an atom will release, or the number of electrons that an atom will lose, or number of electrons that an atom will share. To attain the stability is called as valency, right? So the stability is there, right? So we can simply say something like this: number of electrons that an atom will lose, number of electrons that an atom will gain, and number of electrons that an electron will share is called as the valency. That is the idea of valency, right? Now, if the atom is creating only the covalent bonds, if the atom is creating only the covalent bonds, the number of covalent bonds, including dative bonds, is the valency of that atom. Because we know dative bond is also a covalent bond, right? So we can simply say, if the atom is creating covalent bonds only, including the dative bonds, right? So the number of covalent bonds plus dative bonds is called as the valency of that atom. Now let's check the valency of these given elements. Lithium, we have given beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So valence shell configuration is very important. NS1, NS2, NS2, NP1, NS2, NP2, NS2, NP3, NS2, NP4, NH2NP5, right? So here, in order to attain the stability, this will release one electron or lose one electron. So therefore, the valence is 1. In order to attain the stability, this will release electrons. Beryllium, it will release electrons. So the valence is 2. Boron, it will release or it will share. Both will happen, right? So the valence is 3 here. Because boron can create ionic bonds and as well as covalent bonds as well. It shows some mixed characteristics. Because releasing 3 electrons is quite hard. If it is possible, it is creating covalent bonds as well. For an example, BF3 appear in the Lewis structures. So this is creating covalent bonds. Right? Carbon, for sure, it is creating covalent bonds. So maximum carbon can create 4 covalent bonds. Right? Like for an example, CH4. Because it has 4 electrons in the valence shell. So it will create 4 bonds. How about nitrogen? We know nitrogen is having 3 unpaired electrons, right? And also we know when it is creating NH4 plus ions, it is creating, appear and it is creating a dative bond in between H plus ions and nitrogen atom. So this is a dative bond. At the end of the day, it is created 3 covalent bonds and 1 dative bond. Overall 4 covalent bonds. So therefore, the valency here can be maximized up to 4 for nitrogen, right? I'm talking about the valency. Oxygen, it is always gaining. It is not releasing, right? It is always gaining 2 electrons from outside. Yeah, I think it is satisfied enough, right? So the valence is 2 here. Fluorine was only 1. It is taking from outside, so it is 1. Now this is about the valency. So valency, you have to be very careful how to decide the valency, right? ඔයාලව ලියන පොතක ලියන තැනක හරි කොහොම හරි මෙන්න මේ පොඩි note එක දාගන්න about this valency. Right? Write down this one. The number of electrons, the number of electrons an atom loses, number of electrons an atom loses, comma gains or share, share, S-H-A-R-E, share to form a stable, to form a stable chemical bond, to form a stable chemical bond is called as valency, is called as valency. If the element is creating only the covalent bonds, if the element is only creating covalent bonds, number of covalent bonds including dative bonds, number of covalent bonds including the dative bonds that an element can create, that the element can create, that the element can create is called as, is called as valency of that element, valency of that element, right? Can you write on this one as well, like uh, this set, this is about the valency. Right, hope you have done this one. So let's move into the next one. Now we have some other situation as well, like this. We haven't done something like this in our scope yet. Now let's say I will take HNO3. අපි මේ වඳින්න ලබන සතියේ මේ upcoming Sunday. Now if you take HNO3, HNO3 is having something like this, the structure, right? Now here also nitrogen is showing 1, 2, 3, and 4. Valence is 4. So likewise, I will explain you while I'm drawing the chemical bonds and nitrogen related chemical bonds. I will be explaining there are some very rare situations where nitrogen is having valency 5 as well, but it's very rare. In your scope, that is called as maximum is 4. Most of the time that is 4, not most of the time. Most of the time that is 3, but it can show 4 as well. Very rarely it can show 5 as well, right? Because we haven't done P block yet. After that I will explain. So let's go to the question. In the question, it has been asked, the series of elements lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, the highest valency, decreases from lithium to fluorine. We can't say like that. Increases from lithium to fluorine. That is also we can't say, because it is increasing only up to nitrogen. Then oxygen and fluorine, that is decreasing, right? It is maximizes at C. We can't say like that, because it is maximizing in the nitrogen as well. That is equal, but it is maximum at nitrogen. That is also can be taken. So the most accurate one is it is maximum in nitrogen. After that, that is a decreasing. Is a maximum at oxygen? It can't be, because oxygen valency most occasionally, most of the time, it is 2, right? It can't show more than that as well. So the answer should be the fourth one. Make a past paper ගාන ඒකෙදි maximum at C කියන එකට උත්තරයට හරි දීලා තිබුණා, right? Because there are arguments like logically we can say why it is maximizing C and both of them are equal, why you are not giving marks for C. So they have given the marks for C as well at that time. This is actually a past paper question, not mine, right? Very old one, I think that is 1983 or 1984, I can't exactly remember. Then the fourth one, we will rush through this one. Which of the following is the first ionization energy lowest? So by looking at this one, francium is in the, I think that is in the 6th period or something like that. So no need to argue. So this should be the lowest first ionization energy. All of others are in the higher position of the periodic table. Like for an example, potassium is in the 4th period, beryllium, boron is in the 2nd period, beryllium is also 2nd period, lithium is also 2nd period. So the lowest one, definitely no argument, that should be francium. Francium is in the first group, if I am not mistaken. These are the elements: first, second, third, fourth, fifth, sixth, seventh. It is in the 7th period. So definitely it should be the lowest ionization energy. So the answer should be the 5th one. The next one, the maximum valency of the element of atomic number 32 is, you have to write down the electronic configuration for this one and check what is the valency of this one. Valency, most of the time, it is the number of valence electrons in the outermost shell, but it depends on the group as well, right? So here, let's write down the electronic configuration for this one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now this is 30 up to 4s2, then 32, then 4p2. So 4s2, 4p2 means, if you check the previous note that we have written here, this one, the valence configuration is related to 14th group. Very sorry, 14th group. So the valency should be 4. The maximum valence should be 4, right? So we are talking about germanium here. If you check the periodic table, that is GE, if I am not mistaken. So that is also in the 14th group. If an element is in the 14th group, electronic configuration, valence electronic configuration is ns20p6. Hence, the maximum valency should be 4. So the answer here should be the third one, right? Okay. If there are any questions, you can ask me. Huh? Zinc 2 plus is isoelectronic with. Good question, right? So we have Cu2 plus nickel, As3 plus copper, and selenium 4 plus ions. So the zinc is, you have to check from the periodic table, is in the 30th element. Atomic number is 30, right? So that should be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. So that is the zinc. Zinc 2 plus kilograms. Zinc 2 plus is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So this is zinc 2 plus, right? And this is having 28 electrons. Isoelectronic means same number of electrons. That is the meaning of isoelectronic. Same number of electrons, right? So we need to check which one is having the same number of electrons, right? So the copper is 29, right? Atomic number is 29. Copper 2 plus is should be 27. So this is not isoelectronic, right? Then nickel is 28. So definitely that should be the answer, right? Arsenic 3 plus you can check, and the cobalt is 27. You can check it from there. Cobalt is 27. And selenium I can't remember actually, right? These are not needed because answer should be nickel. Isoelectronic, 28 elements, 28 electrons are with nickel, right? You can check that one. Then the next one, which one of the following is not isoelectronic? So you have to check total number of electrons in such a question. No, don't check only the valence electrons because they are talking about isoelectronics, right? Isoelectronics means total number of electrons should be equal, iso, right? So here carbon is having 6, oxygen is having 8. So this is 14. Oxygen, 8 plus 8, that is 16. Nitrogen, 7 plus 7, that is 14. Cn minus, minus එකක් තියෙනවා මේක මේ පේන්නේ නැත්තම් එතන minus එකක් තියෙනවා. Carbon is 6, nitrogen is 7. Minus means there should be plus 1 because one additional electrons has been added. So altogether that is 14. Here nitrogen is 7, oxygen is 8, plus, that is NO plus, right? So this is minus 1. So altogether this is also 14. So which is not isoelectronic? So the answer should be O2, second answer. යන ස්පීඩ් එක වැඩිද මේ මට මේක ඉවර කරගන්න ඕන නිසා මම කරගෙන යන්නේ. If there are any questions you can ask me. Right, the next one. So see, like, in order to do these kind of things, you should have the understanding how much of electrons are there, what is the group, where is those elements in the periodic table. So your eye should be and your brain and your mind should be combined together. Where is these electrons and how much of electrons are there? So likewise you need to understand, right? That is a question. What is the answer for fifth question? Wait, where is the fifth question? Maximum valency of the element of the atomic number 32. If you have a Miss Puta, this one, the valence configuration is 4s2 4p2, right? So maximum number of electrons are 4 here. So if this is having 4, sorry, Buddha?
මේ 6ට 6 අපි ඩිස්කස් කරාද? ඒ කියන්නේ ෆිෆ්ත් වන්න එක ඩිස්කස් කරලා 6ට නෙමෙයි උත්තරේ 6 උත්තරේ නෙමෙයිද අපි ඉස්සර කරේ.
වරද්දලා නේද?
ආ.
Right. Thank you. So the fifth one answer is fourth one. Thank you. That one I have missed, no? Okay. Sixth question we haven't discussed. I missed that one because I was in a rush to complete this one. The number of electrons in the first sub-energy level of an atom of the element of atomic number 40 is. The number of electron in the first sub-energy level in an atom of an element of atomic number 40 is number of electrons in the first sub-energy level of an atom. So here, no need to write down this one as well. The first sub-energy level is, we are talking about here 1s. Even though that is 40 or 50 or something like that, they are talking about the first sub-energy level. මේ පරණ ගණන් මේ ලේසියට දාලා තියෙන ඒ දවස්වල sub energy level කියන concept එක හරිම මේ අලුත් concept එකක්. ඒක තමයි මේ වගේ ගණනක් දාලා තියෙන්නේ. So the first sub energy level they are talking about 1s. So 1s can have maximum 2. So answer should be 2. So the correct answer is the fourth one. This one. Total number of the electrons is 2. Next one. The number of electrons in the outermost energy level of the dipositive cation, which is made from the atomic number 29 is. Okay. So they are talking about the number of electrons in the outermost energy level. After creating the dipositive atomic number, dipositive cation, the atomic number is 29. Abyssal 29 29 is 1s2, 2s2, 2p6, 3s2, 3p6. Here 4s2, 3d9 ඉන්නේ. හැබැයි මේක එක හැදෙනවා 3d10, 4s1 කියලා. You know those things, right? So this is 29. So the dipositive one is 2 electrons should be removed from the outermost shell onwards, right? So it should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 will be removed and 1 will be removed from D, right? So it would be 3d9. So the outermost shell is this one, the main shell, right? Outermost energy level. So main energy level they are talking about. The total number of electrons is 9 plus 6 plus 2. This is how much? 17, right? So the answer should be the third one. We have to be very careful when writing down 29. 29 we have discussed this one. So that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. This is the accepted energy electron configuration. When it is releasing 2 electrons, it has to be released from the outermost shell. So it should be 3d9. So altogether 9 plus 6 plus 2 will be there. 17. So the answer should be the third one. Right. Next question. An atom X forms a cation of charge +2 readily an atom X forms a cation of charge +2 readily with dilute acid. That is something chemistry is given. The number of electrons in the last energy level of the cation is. Now they are talking about the atom is creating +2 and they are asking what is the outermost electron configuration or electrons in the outermost shell. Now, this is a tricky question. Now, for an example, if you take 14th group elements, now they are talking about it is creating a dilute acid, sorry, +2 1 +2 cation with after reacting with dilute acid. So which means it has released 2 electrons. So what are the elements that can release 2 electrons is first group elements cannot release because the electronic configuration is NS1. Then let's go to the second group that is having NS2. Okay, that can create +2. Right? Then NS2 NP1. It is creating +1, but it is very rarely creating +2 because after releasing 2 electrons, it is gaining NS1. Right? So NS1 is an unstable configuration. So therefore, it is not releasing, very rarely releasing 2 electrons to attain +2 configuration, but it is releasing 3 electrons to gain +3 cationic charge. So this one can be, this one cannot be, right? So let's go to next one, NS2 NP2. It can release 2 electrons because it can gain NS2. No, it will not release 3 electrons. Definitely, it will not release 1 electron, right? Because it is NS2 NP1 after releasing 1 electron. That is unstable. It will release 2 electrons to attain NS2, correct? Then it will not release 3 electrons, but sometimes it will release 4 electrons, which is very hard to attain +4. But something it can create, right? So NS1, it is not there. This can be there, but 14th group is also can be there. 15th group, NS2, NP3, these are not releasing electrons. These are gaining electrons. Release release. So therefore, they are gaining electrons to attain the anion status, right? So this is like -3. If anion is creating, it is gaining electrons in order to achieve the most stable configuration. Otherwise, it will not gaining electrons. Then NS2 NP4 -2 charge or -2 cations. NS2 NP5 -1. Now, by the information, so these are the possible anions and cations. I'm not saying always, right? Most of the time, what are the charges of anions and cations that they are forming, right? So NS1 is creating +1 actually after releasing 1 electrons. So these are the possible anions and cations. Most probable ones I'm talking about, right? We know about the stable configurations and unstable configurations. So your mindset, your logic should be behaving like this. Now, according to this logic, second group and that means it can have 2 electrons in the outermost shell and it can have 4 electrons as well in the outermost shell. But that information is not given in the question. Information given in the question is, this one. Information given in the question is an atom X forms a cation charge of +4 readily with dilute acid. It can be +2. Sorry, it can be second group, it can be 14th group. Either one of them should be there. But information is not enough. Information is not enough to separate these two, whether it is second group or 14th group. Right. So therefore, the answer cannot be the first one because it can be 4 as well. අපිට 4 කියලා දීලා නැහැ තමයි. දීලා නැහැ තමයි ආන්සර් එක. එහෙමයි කියලා අපිට මේක 4 කියලා 4 නෙවෙයි කියලා කියන්න බෑ. Sorry, 2 කියලා කියන්නම බෑ. Because it can be 4 as well. So therefore, the answer here, the most appropriate answer is the fifth one. A definite statement cannot be made regarding this number. because we can say it is second group or the second 2 electrons or 4 electrons. We can say both of them. But මේ පාර උත්තරේට ඔය කට්ටිය ආගියු කරලා මේකත් පාස්වර්ඩ් ක්වෙස්චන් එකක්. ෆස්ට් එකටත් හරි දුන්නා. හැබැයි most appropriate answer is the fifth one. We can't make a definite answer for this one. So answer should be fifth one. Can give the marks for the first one as well. හැබැයි මතක තියාගන්න ඕන +2 cations can be created by 14th group elements as well. For an example, lead is creating +2 PbCl2, right? So that is creating a +2 cation after interacting with the dilute acid, right? Then the next one, W, X, Y, X and Z are 4 non-transition elements. Non-transition elements means they should be in your scope. You have to understand. Transition elements means the D block elements. Transition elements means the D block elements. So they should be in S and P blocks, not D block, right? So that is what we can take from this statement. Non-transition elements with the consecutive atomic numbers are consecutive. Those are consecutive atomic numbers. Period. That means in the periodic table, it can be in the first group and going up to the 18th period and going up to the 18th group, and it should be it could be starting from the next period first group as well, because those are also having consecutive atomic numbers, right? The first ionization energies, that is also something important. WXY, 80 විතරයි දීලා තියෙන්නේ. It is gradually increasing. WXY. So those three are gradually increasing, right? W is the lowest, then next, then Y. Z is a metal. That is a point. Z is a metal, right? So this is an important point. Z is a metal. The electronic configuration of the outermost shell of Z, make a Z Z of the type, right? Z of the type. Then අපි මේකේ ionization energy කතන්දරය අපි යන්න තින් එහෙම 6 pattern එකකින් මෙහෙම එකයි second period, first second group 13 14 15 16 17 18. Then WXY consecutive 3 elements. Consecutive 3 elements are having continuously increasing ionization energies. Here, these 3 are consecutively increasing. Then these 3 also having consecutive increment. So WXY could be 13th, 14th and 15th or 16th, 17th and 18th. හැබැයි අපිට hint එකක් දීලා තියෙනවා. Z, ඒ කියන්නේ ඊළඟට තියෙන එක is a metal. If Z is a metal, it definitely cannot be in 16th group, because the මේ set එක කියලා ගත්තොතින් මේ කොළ පාට set එක කියලා ගත්තොතින් WXY, Z should be the 16th group, but it cannot be 16th group because we have been given it is a metal. So 16th group is having oxygen, sulfur, selenium, tellurium, blah blah blah. So those are non-metals. Oxygen is a non-metal. Sulfur is also non-metal, right? But let's check the next one. The next set is 16th, 17th and 18th. Then the next one should be in the first group. First group then period first group then Z is a metal concept understood? So Z is a metal means it is in the first group. Now we are asking what is the outermost shell configuration or valence shell configuration of Z. It should be NS1, because that should be belongs to the first group, right? So the answer should be the first one. එතකොට මතක තියාගන්න මෙතන කාරණා දෙකක් තියෙනවා. එකක් If there is a consecutive increment in the first ionization energies, ඒ වගේ තැන් දෙකක් තියෙනවා in the first ionization energy graph. That is from 13th to 16th, sorry, 13th to 15th, including those two, or 16th to 18th. අනිත් තැන්වල පොඩ්ඩක් හැදෙනවා, right? It is a drop in the 13th and it is a drop in the 16th as well. So තුනක් තමයි එක දිගට වැඩි වෙගෙන යන්නේ. So if it is a metal, that is that should be belongs to the first group. That is electronic configuration is NS1, NP0. Right. Then the 12th one. The statement කාරණා ටිකකට තමයි මෙතන එන්නේ. හොඳට අහගෙන ඉන්න. Right. Which one of the following statements is not true regarding the elements in the periodic table? Which one of the following statements is not true? Not true. Maybe getting any other control is not true. Not true. Right. Regarding the elements in the periodic table. Elements with one valence electrons are metals. Who says this is correct? Now we talk about valence. Who says this is correct? Who says this is not correct? What do you think? Elements with one valence electron are metals, right? Or valence is one, are metal. Let's go to that valence chart, right? So in our valence chart, you see that they're testing your knowledge about these two, about this one and this one. 17th group elements are also having valency 1. First group elements are also having valency 1. So if we are talking valency is 1, it is not only metals, because we know, yeah, first group elements are metals. All are metals except hydrogen, right? But 17th group is also having valency 1, because that needs only one electron to be gained. And so valency it can be gained or it can be loose. Both of them should be there, can be there, right? So if the valency is 1 means, right, we can't say that it is a metal. It can be non-metal as well, because valency is 1 in the 17th group as well. 17th groups are non-metals. Fluorine, chlorine, bromine, iodine, all are non-metals. So the first statement is wrong, right? So first one is wrong. අපි අනිත්වත් බලමු. එතනින් අපි නතර වෙන්න හොඳ නැහැ. උත්තරේ first එක තමයි not true නේ යන්නේ. ඒක උත්තරේ first එක වෙනවා, but let's check the others as well. There are metals, these are නෙවෙයි. There are metals as well as non-metals in group 14, right? මේ වගේ දෙයක් මට ඔයාලත් එක්ක discuss කරන්න ඕන වෙලා තිබුණේ. 14th group elements are මේක අපි in detail discuss කරනවා P block එකේදී, but you can do this one by using common sense as well. 14th group elements are carbon, silicon, germanium, stannous, and lead. So these are the elements. Carbon is a non-metal, right? Silicon and germanium are semi-metals. Like they are used to create the silicon, the semiconductors as well. Sometimes they conduct electricity, sometimes they are not conducting electricity. So it is in between, right? Stannous and lead, you know, lead is a metal, right? So these are metals. So 14th group is pretty important, pretty interesting one. They have non-metals as well, and they have metals as well. So there are metals as well as non-metals in the 14th group. Yes, that is correct. හැබැයි මේ උත්තරේ වැරදි, because we have been asked about not true. Make a hurry statement is correct, but for the question This is wrong because we have been asked what is not true. Most elements in group 13 are metals. So group 13 is boron, aluminium, boron, aluminium, and what is next one? Can you check
Gallium.
now? Gallium,
Gallium.
gallium. Yeah, gallium, indium, and thallium. Thallium. Thank you. A little bit. Yeah. So these are the elements, right, in the 13th group. So this is non-metal. All of these are metals, right? So all others are metals. You know, aluminum is also a metal. Gallium, indium, thallium, those are also metals. Except thallium, you can consider that part. So most of the elements in group 13 are metals. This is correct, right? Then all 3D transition elements are metal. There is no argument. They are metals. That is correct. Group 17 contains elements that exist as gas, liquid, or solid at room temperature. මේකත් ඉගෙන ගන්න ඕන කාරණාවක්. Group 17, those are fluorine, chlorine, bromine, iodine, and astatine. Forget about astatine. Astatine is a radioactive element. Fluorine is a gas. Chlorine is a gas. Bromine is a liquid. Iodine is solid. Astatine is also a solid. So 17th group is one of the rare group where we can see gases, liquids, and as well as solids are in the same group, right? So remember, bromine is a liquid. There is another liquid that we can see in the periodic table, that is Hg, mercury. Mercury is also liquid. There are very rare metals. There are very rare metals which are liquids. Hg is a metal liquid, right? In the room temperature, it exists as a liquid. Bromine is also a liquid. So not only the metal liquids, liquid elements are also very rare, right? So 17th group is a very interesting group. We can see gases, liquids, and as well as metals. Sorry, the solids are also in the same group. So the 5th one is also correct. But we have been asked which is not true. So the answer should be the first one. Answer should be the first one. Then the next one. Which of the following statement not true? I get that not true. Okay, is not true regarding the ions N3 minus, O2 minus, F minus. Right. So those has been asked. Okay. So they have the same electron configuration. Let's say this is atomic number 7, this is 8, this is 9. They have gained some electrons to create the anionic configuration. So this is 10, this is also 10, this is also 10. So first one is correct. They have the same electron configuration, that is correct. Nuclear charge follows the order. Yeah, nuclear charge follows the order. Nitrogen is 7, oxygen is 8, fluorine is 9. That is also correct. They have the same number of electrons, not elements. Electrons. This is electrons. As neon, yes, neon is 10. They have the same number of electrons. That is also correct. Then the next one is, fourth one is, they are ready, follow the order N3 minus, O2 minus, and F minus. Actually, this is not correct. So they are ready, the highest is with the N3 minus ions because 10 electrons is looked after by 7. So this is should be the highest. Then O2 minus, then F minus ions. So fourth one is wrong. None of above කියන එකත් වැරදි. ඒක අපිට ගන්න බෑ තරක් විදියට. So the answer should be the fourth one. හැබැයි fifth one එකත් ගන්න පුළුවන්. None of above. මේක උනට logical නෑනේ. So the answer should be the fourth one. Then the next one, 14th one. Which of the following statement is not true? Right? Which of the following statement is not true? Okay. Now let me erase these things. Radius of H minus ion is larger than that of helium ion. Helium atom. Hydrogen H minus and helium. Hydrogen atomic number is 1, here it is 2. Here the number of electrons is 2 because hydrogen is having 1 electron has been additionally added. Helium is also having 2 electrons. So 2 electrons is looked after by 1 proton. Definitely it should be higher radius than helium because 2 electrons has been looked after by 2 protons in helium. But 1 proton is looked after by 2 electrons. So helium minus ion. So H minus ion should be having a higher radius than the helium atom. So that is correct. අපි මේකෙත් දහන්නේ not true කියලා. Helium has the highest first ionization energy of all atoms. That is definitely correct. Not hydrogen, helium. F does not show positive charges. Fluorine does not show positive charges. Actually, fluorine is the highest electron negative element. Highest electron negative element means it is not releasing electrons, it is gaining electrons compared to others. So fluorine cannot create positive charges. So this is wrong. Right? Fluorine cannot create positive charges because nobody is going to take electrons from fluorine because fluorine is having the highest electron negativity. Logics, right? I'm not in detail in the P block, but you can understand the things, right? So fluorine is having the highest electron negativity. Highest electron negativity means it is not releasing any electrons to gain the positive charge because there is nobody to gain electrons from fluorine. Fluorine is attracting others electrons as well, right? So that is wrong. Oxygen minus මේකේ logic එක ඔයාලා දන්නවා මේක ගන්න හැටි. O minus gas plus E converts into O2 minus gas. Now they are asking the process needs to absorb energy. Absorbing energy means end result is unstable because it is having higher energy after the absorption. Absorb කරනවා කියලා කියන්නේ after the absorption it is having higher energy. So now make a statement එක හැටියට O2 minus is having higher energy. So O2 minus higher energy means this should be unstable. Right? So if it is need to absorb energy, O minus should have low energy, which means this is stable. Then මේ දෙක ගත්තාම O2 minus, sorry, O minus is having NS2 NP5 configuration because oxygen is having NS2 NP4. It has gained 1 electron, NS2 NP5. Then O2 minus ගත්තාම it is having NS2 NP6. Out of these two, this one is having NS2 NP6 is having highest stability. So if this is stable, this is unstable. So actually this process is going from instability to stability, right? So if somebody is giving, or if somebody is going from instability to stability, it should release energy because at the end result is having low energy, it is having high stability. So relationship between stability and the energy is higher stability is having low energy, right? Then මෙයා යන්නේ in order to the stability. If it is going into the stability, it should release energy, not absorb energy, right? So this statement is wrong. needs to absorb energy. This is also wrong, right? Process needs to absorb energy. That is wrong. N2 gas can show metallic properties. මේක ඔයාලගේ ස්කෝප් එකේ තියෙන එකක් නෙමෙයි. හැබැයි මම මේක පොඩ්ඩක් explain කරන්න try කරන්නම්. Sodium is having 1:2, 2:2, 2p6, 3s1. Right? Now, when sodium is in gaseous state, they are in. We know sodium is metallic, right? Sodium is metal. It is showing some metallic characteristics, right? So when sodium converts into gaseous state, it is having here and there elements. One is here, one is there, other one is here. So likewise, it is having longer distances. So this NS1, 3s1 is kind of a trouble for them in the gaseous state. So what they do is, two of them will combine together and it will attain NS2 configuration. So they are sharing these two electrons in the gaseous state. Make me solid state in the gaseous state. So sodium in the gaseous state is in the Na2 gas form. Na2 gas form, right? So Na2 gases, even though that is also sodium, right? It cannot show, because metallic property means අපි ඉගෙන ගන්නවා දැන් ඉස්සරහට අපි මේ Lewis structures ඉවරනාට පස්සේ අපි කතා කරනවා metallic structures. What is a metal can release electrons. So if somebody can release electrons, it can show the metallic characteristics because electrons are released. So when it comes to Na2 gas, it cannot be releasing electrons because those two electrons, the two electrons from sodium 1 and sodium 2 has been shared each other. If these two are shared each other, there is no way to release it and show the metallic characteristics. Releasing electrons to a pool is a characteristics of a metal, right? So the second one is also wrong, right? So actually, අපෙන් අහලා තියෙන not true කියන එක මේ ඕන තුනේ එකක් ගන්න පුළුවන් ප්‍රශ්නයක් නෑ මේ ගානේ ප්‍රශ්නයක් තියෙනවා මේකේ. That's the issue, right? So F does not show positive charges, that is also wrong, right? So sorry, F does not show my issue. F does not show කියලා තියෙන්නේ. F does not show positive charges means that is correct because it is only showing the negative charges. මම මේක කියවගත්ත වැරදි. ඒ කියන්නේ not true කියන එක නෑ. F does not show positive charges, that statement is correct. Not showing positive charges, that statement is correct because it is only showing the negative charges, right? Sorry about the mistake. Then fourth one or fifth one can be there. Out of these two, the most appropriate one is the fourth one, not the fifth one, because that is from your scope, right? මේ දෙකම හරි. තුන්වෙනි එක පැටලුවද මම? නෑ නේද? Fluorine does not show positive charges, that is correct, right? Because fluorine can only show negative charges. It cannot show positive charges because it is having the highest electron negativity. It can't show the positive charges because nobody can take electrons from fluorine, right? Then the 15th one, X, Y, Z are consecutive elements in the same periodic table. Z is a gas under normal conditions. The first ionization energies of these elements are order X, Y, Z. මේක ආය අහලා තියෙනවා. X, Y, Z, the electronic configuration of X is of the form. දැන් කලින් කතන්දරෙමයි. මේකෙදි කියනවා Z, X, Y, Z are consecutive elements in the same period of the periodic table. Z is a gas. So Z is a gas now. They're talking about a gas. X, Y, Z consecutive. Z is a gas. Under normal conditions, first ionization energies of these elements are order X, Y, Z. ඒක පිළිවෙලට වැඩි වෙගෙන යන තුනක් තියෙනවා. X, Y, Z. And Z is a gas. The electron configuration of X of the form. X එක මොකක්ද කියලා අහන්න. Right? අපි අර ඉස්සර වෙලා n දෙකටම අපිට යන්න පුළුවන්. ඕකේ කියන්නේ තුනක් තියෙනවා. X, Y, Z විදිහට යන්නේ. Z is a gas. Right? එතකොට අපි ගත්තොතින් එහෙම මෙන්න මේක Z2 කියලා කියන්නේ it could be either 15th group, it could be either 18th group. If you consider 15th group, nitrogen is there. So nitrogen can be a gas. 18th group, helium, neon, argon, krypton, xenon, all are gases. So this is also a possible option. Right? එතකොට මේ දෙකේම තියෙනවා මේ gases possibilities. X, Y, Z gradually consecutively increasing. They are consecutive elements. So the Z is a gas means it could be a candidate in the 15th group, or it could be a candidate in the 18th group as well. But we have been asked what is the configuration of X. So the X could be either it could be in the 13th group or in the 16th group. If it is in the 13th group, electronic configuration should be NS2NP1. Answer can be this one, or it could be from the 16th group. 16th group means NS2NP4. So either 1 or 4 are correct answers. Because XY is a gas. Gas means it could be nitrogen or phosphorus. Phosphorus is a solid there, but it could be nitrogen. There is a possibility. But definitely 18th group elements are gases. So X could be either in the 16th group or in the 13th group. So both the answers are correct. Make a past paper question. Right. The next one. Which of the following is having the smallest radius? Cations are having the smallest radius. So you can check magnesium 2 plus is the lowest radius out of this set that has been given. You can check, right? You know how to check them. So the answer should be the fourth one. The 17th one. Cationic radius of lithium, barium, and magnesium are. Barium should be the highest because that is in the, I think in the 6th period. Then should be the magnesium. Magnesium is in the 3rd period and lithium is in the 2nd period. So lithium should be the lowest, magnesium should be next, then barium. Remember, this is not beryllium. They have been asked about barium. This is a very simple question. So the answer should be the 5th one. Similar answer, right? This should be the answer. Then the next one. Last one. The atom X forms anion X2 minus. Atom Y forms Y3 minus. The number of electrons in the last sub level of these two anions are NX and NY. Number of electrons is the number of electrons in the, it should be not is, in the last sublevel of these two anions. This is NX, this is NY. Respectively, what are the relationship between NX and NY? So, if the atom X forms the anion X2 minus and Y forms the anion Y3 minus, the number of electrons in the last sublevel of these two anions NX and NY. Now, I told you, Buddha, always anions are anions are forming to create stable configurations. So for an example, let's say oxygen and nitrogen. Oxygen is creating 2 minus ions, nitrogen is creating 3 minus ions. Both of them are having same noble gas configuration at the same period. So which means this is having neon configuration, right? For an example, let's say S2 minus and Cl minus ions. Both of them are having same electronic configuration as argon. So if an anion is creating to form the most stable configuration. So therefore, both of these two should have the same number of electrons, these anions. So logic is, the theory is anions are creating to form, or anions are formed to create the most stable configuration. Most stable configuration is the noble gas configuration in the same period. So we have to assume that this X and Y is in the same period, and we have been asked about the electronic configuration of these anions. this electronic configuration of these anions should be equal, and the last subshell should be P, not D, right? P is having 6 electrons because noble gas configuration is NH2 NP6. Anion එකක් හැදෙන්න ඕන. Anion එකේ the number of electrons should be equal. That equal number of elements should be equal to the noble gas configuration of the same period. The last subshell should have 6 electrons. So the answer should be the fifth one. Nx equals Ny equals 6 electrons. Make it xy ගැන නෙවෙයි. See, the last the electrons in the last sublevel of these two anions. Anions ගැන. So anions is having same number of electrons. If we have been asked about the electronic configuration of the X and Y, then definitely Y is having lower electrons than X because Y has taken more electrons. If Y has taken more electrons means it should have lower number of electrons in the last sublevel compared to X. So, but we have been asked about the anion. Anion electronic configuration should be equal, but we have to make an assumption here. The assumption is X and Y are in the same period. නැති වුණත් ප්‍රශ්නයක් නැහැ. පොඩි assumption එකක් දැම්මට ප්‍රශ්නයක් නැහැ. අතත් කමක් නැහැ මේකෙදි because -3 and -2 both of them should be creating the noble gas configuration. Noble gas configuration last sublevel, that is P, should have 6 electrons, right? So that is the end of this paper discussion, right? That is ST9. ලකුණු දාගන්න කොහොමද ගත්තේ කියන එක නොදන්න දේවල් තියෙන්න ඇති. බොරු වෙන්න එපා ලකුණු අඩුයි කියන එක. ඉගෙන ගන්න දේ තමයි වැදගත් වෙන්නේ. මේ දේවල් ටික ඉගෙන ගන්න, short notes හදාගන්න, create your own short notes and answer the questions. Clip to the paper. පිළිවෙලට මේ වැඩ ටික යන්න ඕන. එතකොට මේකේ දේවල් මම ගොඩක් දේවල් කියලා දුන්නා. We have talked about valency, we have talked about the ionization energies. ප්‍රශ්න කරන්න තමයි අපි මේ කතන්දරේ ගැන අපි ඉගෙන ගන්න. right? මේ හින්දා මේක මේ බොහොම important කාරණාව. paper එකට මේ live එකට එන්න බැරුණත් recording එක හරි බලන්න ඕන. The paper class and the tomorrow class are very important. miss කරගන්න බෑ මේ කතන්දරේ. live වෙනවා නම් මම කැමති බැරි නම් recording එක බලන්න, that's no issue. So අපි හෙට මම ලෙවිසි structures අඳිනවා. මම මේ homework එකක් දුන්නේ. that ඒක මම බලනවා හෙට. sorry බලනවානේ මම කරනවා ඒ ටික. ඊට අමතරව මම complex structures ටිකක් හදනවා අලුත් ඒවා. So join the class tomorrow as well. So have a good night. තෙරුවන් සරණයි. right. හෙට class එක තියෙනවා හොඳේ 10. right. Thank you. Good night.